Hello everyone. Today I am going to discuss another A-level physics question. This will be helpful for English medium A-level students as well as London A-level students. Let's move on to the question. A particle of mass m is attached to one end of a light elastic string of force constant k and unstretched length of L naught. The other end of the string is fixed into a vertical frictionless wall at y equals 0 as shown in the figure. The particle is then projected vertically downwards from the position y equals 0 with a velocity v0, and v0 is less than root 2gl0. Neglect the air resistance. After passing through its lowest point in the path, the particle will again come to rest momentarily at a point whose y coordinate is. Now, you can see in this question there is some situation. So, an light elastic string is attached to a wall. There is a frictionless wall. And this elastic string is initially not elastic, it is loose. And it is placed at the position y equals 0. Then the other end of the string is also attached to a ball. So when we throw the ball downwards with a velocity of v0, we have to think how it moves with that velocity and how does it work in the next process of this pathway, and we have to make the equations according to what is asked in the question. So let's move on to that. As you can see in this picture I have drawn, at the y0 we have given initial velocity of v0 vertically downwards, and in the next picture, the second picture, you can see that it goes downwards with an initial velocity of v0, and it will be increased because of the gravitational acceleration, and in some point the velocity is v1. And then in the third picture we can see that the strength, the string and the ball has moved to some extent. We can see that the string is at its initial elasticity. That means in the second picture the string was loose, but in the third picture that string has not yet started to have an extension, but it is at the very point of beginning of an extension. That means it has not taken an extension, it is the beginning point which it will take an extension. And in the fourth picture you can see that the point A is what? Point A is the position that ball will go downwards another furthermore, and then string will become elastic. That is the beginning of elasticity. And you can see when in the fourth picture, when the ball comes to B position, the ball is stopped. Why it is stopped? Because initially it had the velocity going downwards, and at the A point, due to because this is an elastic string and elasticity is built up. So there is a force building up against the velocity of this ball. So we can see that there is an extension of x. Imagine after having this extension and an elastic force, the ball will be stopped in the position B. And what is happening next? I have shown in the final figure, when it is in the B position, the ball will be stopped. Why? Because there is a force, there is an elastic force that is acting opposite to the direction of the ball. So after having this elastic force, the ball will be turned the opposite way. That means against the gravity. And that ball will be going upwards. When it goes upwards, you can see that the extension of this string will be reduced. That means x is reducing. When x is reducing, this ball will initially come into the A position again. So when it is at the A position, we can see that the extension is no more there. When the extension is not there, you can see again this ball is moving upwards freely because the string is loose. Imagine, as I have shown in the third picture, sorry, I have mistakenly put 2 only, I have used v2 there. So in the third picture, v2 is the velocity at the beginning of the extension. As you can see, when it goes downwards and it is stopped in the B position, and then it is turned opposite to go upwards. When it started to go upwards, it will come into the A position. A position is same as the position that was in the previous situation when the ball was going downwards. So the velocity will become v2 and it is the same. When v2 velocity is now acting upwards. When it is acting upwards, this string and the ball will start to go upwards. When it is going upwards, you can see when it is moving upwards, that is a usual gravitational linear motion. So it goes upwards, and at the y0 position, y equals 0 position, this ball will take the initial velocity. That means it is same as the magnitude that was initially given to the ball to go downwards. So it is same in magnitude, but now it is acting opposite side or against the gravity. Then v0 velocity is taken at the y equals 0 point upwards. And now you can see it is a normal motion, and we can exclude the part that is having an extension and elastic forces. So if we take that into the question, it will be more difficult. So we can exclude the part that is happening in A and B. And then the ball has again come to the y equals 0 position, and then the ball will go upwards furthermore. And you can see now it is a ball going upwards against the gravity with an initial velocity of v0. We can conclude the main parts into that conclusion. What is that conclusion? The ball has taken some experiences at the points A and B. But after that, the ball has started to move in the opposite direction, and it has come into a situation in which there is an initial velocity v0 and the initial point is y equals 0, and it is moving against the gravity. Now we can use a simple equation as I have shown in the right side upwards. We can use the equation v squared equals u squared plus 2as. We can use that equation in the upward direction. And we can see the ball will go upwards, and the terminal velocity will be 0, and the initial velocity will be v0, and since we are using the equation in upward direction, we can use it positive. The gravitational field is acting in the opposite direction, so minus 2gs, and we can take s as v0 squared upon 2g, and that is the answer. But we have given some you can see that it is confusing part. We have given that v0 is less than root 2g L0. What has it told us? Now we can see, imagine if the ball is initially the ball is going downwards and there is some extension and elastic force part, and we can exclude that. After that, ball has again come to the y0 position, and now it is going upwards. When it is going upwards, what would happen? When it goes upwards and when it reaches L0 length, you can see that the string is not loose anymore. When it is not loose, that means it has started its elastic part. If it passes L0, you can see that ball will be stopped in a position with an extension. If it is with an extension, you can see that this question will be more difficult. So they have given v0 equals 2g L0. That means you can see in the right side lower direction, I have given the equation. If I use the v square, the same equation in the upward direction, we can see if the ball moves L0 length, we can use that equation and it will become v0 squared equals 2g L0. That means in a length of L0, v0 squared will be equal to the 2g L0. That means, but in the question, v0 squared is less than that part. That means we can see when it is going upwards, the ball is not moving furthermore from L0. In other words, the ball will be stopped before the string reaches its L0 length. That is the part we have given there. Now, let's summarize what we have learned. In the question, they have asked a ball with the light elastic string, and then initially ball is moved downwards and then it comes upwards, and when it comes upwards, it will come into a position that at the y0, it will have an v0 velocity that is acting upwards. When it is acting upwards, it will go into some length and it will be stopped. v0 is less than root 2gl naught is given because at the upward movement the ball or the string has not taken its elastic length or L naught length. So the ball will be stopped at the in a position which is in between y equals 0 and y equals L naught. Ball will be stopped in the middle path. That is why we have used these equations to measure how much distance that the ball has moved in the upward direction. So we can take it like that. I may be somewhat slow, but it is my English problem. So I hope I have tried my best to give you something. If you like it, subscribe. And we will meet all in another question. Thank you.